About block friction, wedge friction, ladder friction, belt friction, screw frictions, all these things. So now we will try to solve some problems related to these things. Okay. So let us consider a first problem related to block friction. So this problem is related to block friction. Okay. So what they are given us, there is a coefficient of friction which is 0.4 between all the surfaces. They mentioned that. So they are asking you what is the smallest force P which is required so that you can able to move this object, right? So they are considered two conditions. Number one, if there is a cable which is attached like this. The second condition is if there is no cable. If there is no cable, what will be the position, right? So this is your problem. So let us consider. So it is similar to that. Let us consider the first one as 30 kg as block A and this 20 kg as block B. Right now, let us draw a free body diagram for these blocks. So for block A, right? So this is my block. So like this. So you know that if you have a cable attached, I am solving first case, case A, right? So if there is a cable which is attached, what are the forces you have? So you have weight which is acting on this block, which is 30 kg. So we are converting to 9.81. So 30 into 9.81. So if we convert it to Newton, you are getting 294.3 Newton. Then you have a force P which is acting like this along this direction, and you have B, so TAB, so a string which is connected A and B, right? And if you look here, there is a contact. Where are the contacts? There are two contacts, one with B and A, other one with the surface, your inclined surface, so normal surface and your block. Okay, so which means you have two reactions. So the first reaction will be like this. Let me consider this as R1, right? So, and the other one is like this, which is RAB. So here I call the RAB is, it is common to A and B, right? That's why I call this as RAB, right? So this is the situation. Now we have to identify how the object will be moving, right? So how this object will be moving. So when you look here, this object, block P, so this one will move along this direction because you are applying a force here, which means this will move along this direction, right? So since it is moving along this direction, your friction will be in opposite direction, right? The friction, whatever you are applying, is in opposite direction. So which means my friction force will be in this direction, which is mu into RAB. I'm directly writing down, right? I'm not considering F, which is equal to mu into RAB. So I'm directly writing it. Similarly here, we have mu into R1, right? So we know the values of mu. So mu is given, which is 0.4. In that case, I can rewrite this. So this can be written as 0.4 RAB. And this can be written as also 0.4 R1. So these are my overall forces, right? So when you look here, the first step is you identify how many number of unknown forces, right? So unknown force, is there any value given? So there is, they are asking P value. So others are all entered. So you have 1, 2, 3, 4 unknown forces. You have 4 unknown forces here, right? You have 4 unknown forces for this particular block A, right? So next we will connect with block B. We consider block B, right? So block B, you have a block like this. Okay, so what are the values? You have only one force, which is TAB, similar to this, along this direction, and weight of the object, which is acting downward, which is 20 into 9.81. So we're getting 196.2. So 196.2 Newton. And of course, the contact is only in this side. So you have only one reaction, which is RAB, right? So make sure, so if I add, it has to be in equilibrium state, which means this one and this one. So if I add it, it has to be in equilibrium state. So then your friction force in this will be opposite side. So since this is in left hand side towards, so it is moving towards right. So here you have a friction force which is towards left, which is zero point 0.4 RAB, right? Of course, no need to worry about this movement of this block because of this is moving, this will move along this direction. So the movement is mainly where the force is given. The force is given only in block A. So from there only I have to start my problem. I have to draw my free body diagram. Based on that only we will get free body diagram for other blocks. So don't start with B, because sometimes you will get a problem in this friction. It may be in opposite direction, right? You would have mistakenly written like that. So always you consider from where you have known force, from there you start and you try to do it. Okay, so here how many unknown force you have? RB and TAB, there are two unknown forces here, right? Two unknown force. So in that case, which one you have to solve first, block A or block B?
B, sir.
Yeah, very good. So first we have to start with block B. So let me start with block B, right? Let me draw. So block B. So what are the forces we have? So 196 is acting towards downward direction. So this is moving like this. It is 196.2 Newton. Next, TAB along this direction. This is TAB. RAB towards upward direction. So this is RAB. And another RA, zero point 0.4 RAB, which is your friction force, that is in opposite direction. So this is zero point 0.4 RAB. Right? These are all my forces. Right? So only thing is I can say that it is in equilibrium state, which means I can say sigma fx is equal to 0. I can equate it, which means I have only two forces. TAB is equal to zero point 0.4 RAB. That's my first case. Next, sigma Fy is equal to 0. If I equate, so you'll get RAB is equal to 196.42 Newton. In that case, I can substitute it here. I can able to get what is my TAB. Right? What is my TAB then? So you have to multiply with zero point 0.4. So zero point 0.4 into 196.2. So you are getting around 78.48 Newton. Right? So this is my value of my TAB. So now I got all these values. Right? So now it is easy for me. Right? So only step is I will directly go for the uh, other block, right? Because all the values are found here. So let me go for block A now. 294.3, which is downward direction. So 294.3 Newton. R1 towards upward direction. R1. P, force required. P, that is unknown. Then TAB, which we already identified, right? So I am going to substitute the value. So TAB is 78.48. Let me substitute that. So this is 78.48. And then you have mu into RAB. So that is also known, right? Zero point 0.4 into RAB. What is zero point 0.4 into RAB? That is nothing but TAB, right? So zero point 0.4 into RAB is again the 78.48 is acting here, right? So again, so plus 78.48. Another 78.48. Okay, so next this one, right, plus zero point 0.4 R1. So how many forces? 1, 2, 3, 4, 5, 6 forces. Here also 1, 2, 3, 4, 5, 6 forces. You cross verify it, there may be a mistake, right? So you may leave some forces. So better you cross verify. So now I identified all the values.
Sir,
So
RAB downwards. Sir.
yeah. Sorry, that's what I missed one force, which is RAB plus RAB. So RAB we already identified, which is 196.2. So 196 point. Okay. So I substituting here. So I think now it is very good. So it is linked. Now let us proceed with this. So let me consider sigma Fy is equal to 0 because that will be easy for me to solve it. So if I consider sigma Fy is equal to 0, R1 minus all these things is equal to 0. Or I can say upward force is equal to downward force. Upward force is R1, downward force is 294.3 plus 196.2. Right. So what is the value of R1?
490.5.
So 490.5 Newton. Yeah, very good. So we identified this. Now, only thing is I can we can add equate it. Sigma Fx is equal to 0. So you'll get P. So left side force is equal to right side force. So P is my left side force. Right side force is 2 into 78.48 plus zero point 0.4 into R1. So my right hand side force. So which means P is equal to, values. So 2 into 78.48 plus zero point 0.4 into is 490.5. So what is the value of P? So it is 353.16 Newton. Okay, so now there is another problem here. So they said you are consider only case A, which is attached, even the string is attached, right? So what happens if there is no string? That is the next case, right? So let us consider case B. So when I consider without string, so your free body diagram will have a little bit change. You don't have that force. You have force P that is required, that is available, right? And all these things are available except this TAB, right? So I think I can copy this entire thing. There's no difference, right? Except this TAB. So you don't have TAB. So this is not there. Okay, because there is no cable which is attached to it. So this will be the free body diagram for A. Similarly, if I consider for B, right, B is also similar except this TAB. So this is also not available, not required. So only these things are there. Again, if you look here, the minimum number of force is applicable only for B, right? When compared to this minimum unknown forces. So we start with B again, right? So let us identify. So you have 196.2 Newton is acting along downward direction. RA is acting towards upward direction, RAB. So I think the force doesn't require actually. So even if we apply it, we are not going to use that. There is no friction force which is acting along this direction. So because your object is resting, right? So it is like this. So let me consider sigma Fy is equal to 0 now. In that case, I will get RAB is equal to 196.2 Newton. That's the only difference. Okay. So this is over. Let me go for your block A, free body diagram for block A. So you have RAB acting downward. You know the value of RAB, which is 196.2. Let me substitute 196.2 Newton. Then 294, you are adding that. So plus 294.6 Newton. So next, you have zero point 0.4 RAB and 0.4 R1, right? So this side, you have 0.4 into 196.2 plus 0.4 R1. So these are the values. And you at the top, you have R1, right? And left hand side, you have P. Any other force which is missed? Can you see any other force which is missed? I think we have included all the forces, right? So, okay, so now let us equate it. So let me start with sigma Fy. Let me equate sigma Fy is equal to 0. So what will get R1? So R1 will be 196.2 plus 294.3 Newton. So this one. Okay. So similar to, I think there is no change in this. So R1 is again 490.5. So R1 is 490.5 Newton. Right. So now I'll put sigma Fy Fx is equal to 0. Let me put left hand side force is equal to right hand side force, which is zero point 0.4 into 196.2 plus zero point 0.4 into 490.5. So what is the value of P now? 274.68 Newton. So this is my minimum force required, right? So to lift, to move your object, right? So hope you can able to see when it is tied, you have more friction, right? When it is tied with a rope, you have more friction, which means you require more force to move your object when it is connected like that. So whereas if it is not like that, so when it is not connected, then you have less force to move that object. Okay, so there is another test. Any doubt in this particular problem?
No, sir.
Sir, in case in the question if they give the blocks are moving, sir, then we must
Okay.
include that additional MA force only, no, sir, before equating it to 0.
Yeah, that's a good question. So most of you will have a confusion. So to best way to identify is to find the question whether they mentioned you to find out acceleration. Acceleration means fourth unit. If they are not asking anything about acceleration, it is fifth unit. So this is a wedge friction problem. So you have a 200 Newton block which is resting as shown in the wedge. Okay. The coefficient of friction is same. It is given accordingly, which is 0.25. So I think they mentioned the coefficient of friction here, right, which is 0.25. And there is no friction between block and vertical wall. So that means this side you don't have any friction, right? This is free, no friction force along this direction, along your vertical wall, right? And they are asking you to identify what is the minimum force to lift this 200 Newton load, right? What is the minimum force required to lift it? And what will be the force, whether it is lesser than the 200 Newton or greater than that? So that's the question, right? And out of this, I think it is similar to your block problem. So there is no much difference, right? Only thing is there is an inclination here and there is no weight here. Wedge doesn't have any weight, right? So when you look at the problem, the force is applied on the wedge. So the first step is I have to take block B and I have to draw the free body diagram, right? So according to this, so your wedge is like this. This is my wedge. Okay, so if I identify what are the forces, you have force P, which is acting along right hand side. Contact surfaces, you have two contact surfaces. So one you have like this, which is RAB, right? And of course, the angle is vertically. So this is horizontally 15 degree. So this RAB will be perpendicular to that. So vertically, this is 15 degree, right? And you have another force here. So let me consider this as RB, right? So this is a kind of contact with the horizontal surface and your wedge. And now let us look how the object is moving. When I apply a force like this, your wedge will move along this direction, right? So your wedge will move along this direction. So your friction force will be opposite. So which means my friction force will be like this. So this is my friction force, mu into RAB. So mu is 0.25, they mentioned. So this is 0.25 into RAB. And Horizontally, it is 15 degree. Horizontally, it is 15 degree. Okay, it is parallel to the surface like this. And you have another friction force here, which is 0.25 into RB. Right, this is the overall free body diagram for this particular block, a wedge. Any doubt to this?
No, sir.
Okay, now let us go for free body diagram for A. So A is something like this. So you have a block which is like this. This is my block. Okay, so this block is having 200 Newton force. You have a force which is 200 Newton acting downward. When you look at the contact surface, your contact surface is with the wedge and your block. You know that it has to be in equilibrium state. So which means this and adding this should be 0. So RAB. So same thing you have here. RAB should be upward direction. RAB, and the angle is 15 degree vertical. And friction force along this direction, though this has to be opposite direction. So towards downward direction, 0.25 into RAB. And this is horizontally 15 degree. Right, horizontally 15 degree. So other than this, there is a contact here, so which will form reaction. Right, we have a reaction here, RA. Right. So when you look at how this block will be moving, when you apply a force like this, how the block will move here in block A?
Upwards, sir.
Yes. So when you apply a force, your block will move, A will move upward. So since the problem says that there is no friction, you no need to consider it. But if they are not given like that, then you would include a friction force opposite to this direction, which means I have to include it like this, a friction force Fe. Okay. So, but for this problem, you no need. But for other problems, based on the direction of motion, you have to identify that. Okay. So that's why. So, right. Now, let us identify what are the how many number of unknown forces. So B will have 1, 2, 3 unknown force. 3 in B. A is having 2 unknown force. So the first thing is I have to solve A. Then I have to proceed with B. Okay. So let me start with A now. So let me draw what is my force diagram. So you have 200 Newton acting downward. 200 Newton force. RA, right? So RAB, so 15 degree, right? So this is 15 degree. Yes, Ramesh Aravind. Okay. So RAB towards upward direction, and if I consider this one, so if I consider the quadrant, it is in fourth quadrant, right? So which means this one will be like this. So this is 0.25 RAB, and the angle 15 degrees here. Okay, these are my forces. So now I can say that it is equilibrium state, sigma Fy is equal to 0. Right? So we consider sigma Fy is equal to 0, you will get RAB. So bring it to y-axis. So 15 degree will be, so it is reducing. So it is cos, right? So RAB cos 15, right? So this is horizontal force. Leave it. this one vertical force downward minus 200. This one bring it to y again. So your angle is increasing and it is negative. So minus 0.25 RAB sine 15 degree. Right? This is equal to 0. So we can identify. So cos 15. So cos 15 is 0.966. So 0.966 RAB minus 200 minus, so 0.25 into sine 15. We're getting 0.064 RAB is equal to 0. Right? So you can just find out what is the value of RAB. So you have to get 221.72 Newton. Are you getting this value?
Yes, sir.
Right. So now I got what is my RAB. Right. So next I'll go for RA to identify RA. So what I do, I have to equate sigma fx is equal to 0. If I consider sigma fx is equal to 0, RA negative, so minus RA plus bringing this to x-axis. So this is increasing. So RAB sine 15 plus this one cos, so 0.25 RAB cos 15. So this is equal to 0. I can able to identify what is my RA. So I know what is the value of RAB. Just substitute it, find out what is the value of RA. So I get 110.92 Newton. Okay, now I'll go for the next diagram. So which is free body diagram for B. So your P force P which is acting to which is moving along right hand side. RAB, I know what is RAB, right? Let me substitute it. So it is in which quadrant? If I put plus here, it comes under fourth quadrant, right? So RAB is in fourth quadrant. Sorry, third quadrant. It is in third quadrant. So RAB. So RAB value I know, which is 221.75. So 21.72 angle is 15 degree. And this one, so 0.25 RAB, right? 0.25 RAB is in second quadrant. So value here. So I know what is RAB, I will substitute it 0.25 into 2 to 1.72. So I'm getting 55.43. Yeah, 55.43 Newton, and the angle is 15 degree with respect to this. And RB is acting towards upward direction, RB, and 0.2 RB is along this direction, right? So 0.2 RB. So these are unknown values. Okay. So these are my forces. So now what I can do, I can go for sigma Fy is equal to 0. I may equate y direction force. We have RB, this one, plus 55.43 sine 15 degree. So bringing to y direction. This one minus 221.72 cos 15 degree. So this is equal to 0. So I can able to identify what is my RB. Right? Just find out what is the value of RB. You are getting around 200 approximately. So I am getting 199.8, approximately 200. Okay, are you getting the same value? I can go for sigma fx and equate it to 0. So if I consider sigma fx and equating, so it will get P positive value minus, so 55 cos 15. So 55.43 cos 15 degree minus 0.2 RB. So 0.2 into RB is 200, right? So I will put 200, right? So minus 221.72 sine 15 degree. right? This is equal to 0, right? So I have only one data, which is P, 151.150, 150.9. Are you getting that value? 150.9,
Yes, sir.
right? This is the force which is required to lift your object, right? You can able to see here the overall weight of this object is 200 Newton, right? Overall weight is 200. But if you apply a wedge and you apply a force, that is lesser, right? How much percent? 200 divided by 150, which means around you're reducing 25% of your weight by applying by using this wedge, right? So that's why most of the time, so we'll be using something like this as a component, which is used to lift a particular object. Okay, can you able to understand what is this is the main advantage of using this wedge. Good morning to all. Today we will discuss a few more problems related to friction. So I think last class we discussed about block friction, right, and wedge friction. We solved two problems related to that. So today we will discuss about ladder friction first. So after that we will proceed with rope friction. So ladder friction is similar to a moment equilibrium state, right? So whenever you say that if you have a moment, so when I say it is an equilibrium state, so what we will do is we will put sigma fx is equal to 0, sigma fy 0, and the moment at any point is equal to 0, right? So ladder friction is based on that. Whereas the previous problem what we solved, which is your uh, block friction and wedge friction, is related to concurrent forces. You don't have any moment, right? We always say sigma fx 0 and sigma fy 0, and that's it. So whereas in ladder you will also deal with moment also, right? Because you have non-concurrent forces, right? So the question says that you have a 5-meter long ladder, right? So which is leaning against a smooth vertical wall. So when I say smooth, so if you see a smooth vertical, it means that along that side you don't have any friction, right? With an angle of 70 degree with horizontal. So it is given the weight of the ladder is 900 Newton, right? Which is acting at the center. Okay, so 5 meter means it is acting at 2.5 meter. The ladder is at a point of sliding when a man weighing around 750 Newton stand on a rung. Rung means what you can say, yenipadi. So that one we call it as a rung, right? So at 1.5 meter, so from the top, so from the bottom. So if I identify, so whatever we get, that is what we are going to deal. So what happens if the man is standing at 750 Newton at around 1.5 meter from the bottom? So your ladder is sliding, right? It is the point, it is impending. So at that time we say that your friction, right, your friction is equal, and we can equate it and to identify what is the value, right? So let me draw a diagram related to this. So it's like what I can say, you have an horizontal and vertical line. So let me consider, okay, so I think I can take this. Okay, let me consider this. Oh, sorry. So let me consider this. So this is my wall. So one side it is smooth. This side it is a smooth vertical wall, right? Other side it is rough. Okay. So you have a ladder. So which is here, something like this. This is my ladder. And you know what is the distance of this ladder, right? So the distance is around 5 meter, right? So let me use this one. We call this as 5 meter. So overall distance. So this is 5 meter, right? So the weight of the ladder is at 900 Newton, which is acting at the center, right? So which means this is this point. Weight is acting downward, right? So overall weight is around 900 Newton, and the distance with respect to that. So it is at the center, right? So when I say it is at center, it means that it is 2.5. This is 2.5, right? So the angle of the ladder is 70 degree, that is mentioned. So which means this angle, right? This angle is 70 degree, right? So now a man is standing. The weight of the man is 750 Newton. So let me consider this is my location. So here there is a person which is standing here. The weight is 750 Newton at a distance of 1.5 meter from the bottom. So which means this distance, it is 1.5 meter. Okay, so this is my overall diagram. So your 2 points which is having contact. So one is point A, other one is point B. So when you say that your ladder is sliding, so point B location will be moving like this, right? Point B location will be moving like this, whereas point A location will be coming down. Okay, so in that case, so what are the forces you have, right? So you have a reaction here, RA, but you don't have friction. Why you don't have friction? Because it is a smooth vertical wall. Since it is a smooth vertical wall, you don't have friction, right? Friction is zero. Whereas here, if I consider, you have RB and a friction which is opposite to the direction of motion. This is my direction of motion. So opposite to that. So you have friction. So the friction is mu into RB, right? So mu into RB. So these are my forces. So how many forces are here? Can you count and tell me? Yes?
7, sir.
7. No, no, no. So don't think about these things. This is
Five
movement.
forces, sir.
Yes. So you have 5 forces, right? So totally you have 5 forces. Okay. So of course you can able to see that this is non-concurrent force. That's why I say that you should have moment also. You will be having dealing with moment also, right? So these 5 forces, oh, let it be. So what I am going to say is you say that it is in equilibrium state, which means I have to say sigma fx is equal to 0, sigma fy is equal to 0, and moment at any point is equal to 0, right? So usually where we take moment, so we take moment at the location where you have maximum unknown force. So if I locate point A is having only one unknown force, which is RA. Of course, point B is also same, but there are two forces, which is RB and mu into RB, right? So what I can do is I can take moment at point B, right? So this is moment at point B, okay, and I can equate it to 0, right? These are my 3 equations. Just substitute the 3 equations, you will get the value. That's it, right? So let me go one by one. So the first, let me say that sigma fx is equal to 0. So let me add all my horizontal forces. So what are the horizontal forces? You have RA towards this direction. No need to worry about movement direction. So always you consider right side as positive and upward as positive, right? So this is RA. And you have one more force here, which is mu into RB. So minus mu into RB. So this is equal to 0, right? So you have two horizontal forces, RA and mu into RB. That's it. So which means I can write as RA is equal to mu RB. Let me consider this as equation 1. So this is my first step. Right? Next, let me equate sigma Fy and equate it to 0. If I equate sigma Fy is equal to 0, 900 downward, 750 downward. So I can write as minus 900 minus 750 and RB upward. So one RB which is upward plus RB. So this is equal to 0. right? So any other force? Can you able to see any other force? That's it. So one, two, three vertical forces. So we are equated. So in this case, I can able to get what is my RB. So RB is equal to 900 plus 750, right? So you will get around 1650 Newton. This is the reaction. Let me consider this equation 2, right? So I got this equation, and of course I can substitute it, but I don't know mu, right? To identify what is my RE, right? Any doubt up to this?
No, sir.
Any doubt? Yeah. Okay. So now what I am going to do is I am going to take moment. I am going to take moment. At which point I am going to take moment at point B, right? I am going to take for each forces, and I am going to find out what is my value accordingly, right? So in that case, if I take moment, it will consider all the forces. So which is RA 900, 750. Since I am taking moment at B, these two forces will be zero because there is no perpendicular distance. So moment is force into perpendicular distance. So you don't have distance, so this will be zero, right? So remaining all we have to identify, right? So let me consider RA. This is my force. The perpendicular distance is my vertical distance, right? So it is like this. So you have a vertical line, so something like this, right? This is 5 meter. So my force is here. The force is here, which is RA, and this angle, the angle is around 70 degree. This angle is around 70 degree. So I know hypotenuse. I can able to identify what is my adjacent side or opposite side. So I'm going to concentrate on opposite side because I don't want adjacent side for RE. So perpendicular distance should be vertical distance, right? So what I can do, I can equate it. So I can take sine 70 is equal to this x by 5. So what I'll get 5 sine 70, right? So what is the value you are getting?
4.698.
Yeah, you are getting x is equal to 4.698 meter. So which means this distance is 4.698. Similarly, so if this is horizontal force, I need vertical distance. Whereas here is a vertical force, I need horizontal distance, right? So I'm going to do that also separately. So let me consider this one. So it is like this. Sorry. I'm going to put two triangles for different values. So one is 2.5 meter, and this is my force, which is, I think it is 900 meter. So I want this distance. Let me consider x1. This is x2, right? This is 70 degree. So what I can do, I can put cos, right? So x1 will be 2.5 cos 70 degree because it is adjacent side, right? So what will be my x1?
0.855.
So 0.855 meter. Similarly, here this is 1.5 meter. So this is for the 750 Newton, 700 or 750? 750 Newton, right? For 750, the distance is 1.5, right? This is for 750 Newton, right? Vertical force, or I need horizontal distance. So x2 will be equal to, again, 1.5 cos 70. So we'll get x2. So x2 will be around 0.513 meter, right? So if I mark it here, so it is like, let me consider. So I'll put a dotted line here, and this is also a dotted line. So this distance is 0.855, and this distance is 0.513, right? 0.5. So this is my overall values, right? So I got all the values now. So only thing what I have to do is I am going to take moment. Okay, so because I identified all my perpendicular distances, right? Just I am going to take moment. For reference, I am taking this picture again and I will put it accordingly, right? So, okay. So now let me take moment at B and equate it to 0. So RA, force into perpendicular distance. RA into 4.986. So 96. So 4.698. It is rotating in clockwise, right? So negative. So minus RB, force into perpendicular distance is 4.698. Okay. Next, let me consider here. This is rotating in anti-clockwise, positive. So plus 900 into distance is 0.855. Again, the 750 is also positive. So plus 750 into 0.513. Right? That's it. These forces are 0. So this is equal to 0. Right? So only thing is I have RA. So I can able to identify what is my value of RA. Right? So you can identify, try it out. So 245.6 Newton. Okay, so now this is my value. So I got this value also. This is equation 3, right? So only thing is my question is to identify what is the value of mu, right? What is the coefficient of friction, right? So I can equate it. That's it. So I know what is RB, what is my RA. Substitute 2 and 3 in equation 1. So substitute 2 and 3 in 1. What will get 245.6 is equal to, so RA is equal to mu into RB. So mu into RB. What is my value of RB? RB is 1650. 1650. So what is your mu?
0.1488.
So 0.1488. So this is the coefficient of friction. Make sure your coefficient of friction will be from 0 to 1 maximum or 0.9. If you get a 1 point something like that, which means it is wrong. You made some mistake. So there may be a other problem also related to this. What they will do is they will give what is the coefficient of friction. They will ask you what is the weight of the man, right? What is the weight of the man when if he is standing at 1.5, it is going to slide. So in that case, what is the weight of the man? So they will also ask a question like that. So the method and procedure is same. What you have to do, you draw a diagram, you identify what are the distance with respect to that vertical and horizontal, then say that it is in equilibrium state, equate it. That's it. Okay. Only thing is I am adding one more force, a friction force, opposite to the direction of motion. Right? It is always opposite to the direction of motion. Belt friction. So this is a problem related to belt friction. Right? So previously in unit 1 we discussed about frictionless belt drives or pulleys. So which means that whenever you have a pulley, so which is connected to a thread, right? When it is passing over the pulley. So your T1 and T2, I can say that T1 is equal to T2 because there is no friction. It means that your rope is sliding, right? Your rope is sliding, your pulley is not rotating. So when your pulley starts to rotate, then it is friction pulley, right? So consider you have a wheel, something like that, right? When it is connected with a belt or something, if you pour some lubrication, so the belt will slide. It won't make it won't rotate that motor or whatever it is, right? So you can relate something like that, right? So you can able to see that. So you fear if it is a frictionless, if it is a frictionless, which means your T1 is equal to T2, right? So for friction, what happens? There will be a rotation, right? So for a friction, there will be a rotation. For example, so if this is my pulley, right? So this is my pulley. So let me consider, sorry, this is my pulley, in which so you have this T1 and T2, something like this. It is passing over this pulley, something. So this is my T1, this is my T2, right? So assume that your pulley is rotating like this. It is rotating in clockwise. When it rotates in clockwise, what happens is this T2, right? This T2 will be maximum. This is the maximum value. This is the minimum value. This is minimum, right? So in that case, there is a difference. Okay, so at the same time, so I'm going to consider the same thing in a different way. For example, this is my same pulley. So I have a belt which is passing through this. So this is my T1 and it is passing over this, and this is my T2. Let me assume that my pulley is rotating in anti-clockwise direction, right? When this is happening, what happens? So this side will be maximum. The side where the rotation, right? That side will be maximum. The other side will be minimum, right? So there may be a confusion, right? In some book, they will for the formula will be T1 by T2. Some book it will be T2 by T1, right? So there will be a confusion in that. So actually, the formula will be related to the maximum tension and the minimum tension. So the formula is related like this. So T max by T min. T max by T min is equal to e power mu theta, right? Where nu is the coefficient of friction and theta is angle of contact. So this is the angle. So which is having the belt and pulley is having connected, right? That angle that is in theta. But it has to be in radians. You have to substitute in radians, not in degree. Okay. So the based on the rotation, you consider T max. Always your T max will be in numerator and T min will be in denominator, right? So either T1 or T2 or T2 by T1, whatever it is. So my formula is related to this, right? So consider the direction based on that and we will substitute it accordingly. Okay. So let me consider this problem. So you have a cylinder, right, of mass 250 kg. So there is a mass of 250 kg which is supported on the other side. So it is wrapped around the pipe. So the thread is wrapped around the pipe. So they are asking what is the force, F force required so that the cylinder is restricted in moving, right? So what happens if you're not applying this force? What happens? This will fill down, right? So in order to make that in equilibrium state, I have to apply a force. Well, they are asking what is that force, right? If the card is passing at 180-degree, which means only one rotation. One rotation, what is the value? If it is two times like this, if it is 240-degree, then what is the value, right? So what is the value of force? So they're asking you to identify what is your friction value, right? So sorry, the friction is given. They're asking you to identify what is the force value with respect to this. Now let me consider you are not applying any force. Which direction your object will rotate? So your object will rotate like this, right? So this means the mass, whatever you are having, it will be coming down, right? The mass which is having, it will be coming down. So this is maximum. So the force is minimum, right? So the force is minimum and the value which is falling down, that is maximum, right? So when you're substituting formula, be careful in this. right? So maximum should be on the other side. Now, so what is my T max? T max is 250 into 9.82. I'm converting into Newton, right? What is the value you are getting? 52.5 Newton. So this is my T max, right? So according to this, the formula is T max by T min is equal to e power mu theta, right? First case, your theta is 180 degree, right? Your theta is 180 degree, which means I am converting to radians, which means pi. So theta is equal to pi, right? So into pi divided by 180. When you do that, you will get theta is equal to pi. Okay. So now I can substitute it. So T max by T min is equal to e power mu is given. So mu is 0.2. So e power 0.2 into pi. So in your calculator, so on the top of ln, you are having e power, right? Use that. So don't use anti-log. Okay, anti-log is 10 power x. So ln is e power, right? So you substitute it accordingly. So e power 0.2 pi. So what I am getting, I am getting T max by T min is equal to 1.874. Are you getting this value? Right? E power zero point 0.2 into pi. Right? So substitute it, you will get this. So now you know what is my T max, which is 32452.5. Right? So which means, so T min will be equal to 2452.5 divided by 1.874. Is 1308.6 Newton. So T min is on the other side, so which is minimum, which is F, right? So the force required to make the to hold this object is F, which is equal to 1306.86 Newton. This is my force required. Now what I have to do, I am going to consider next case, theta is equal to 540 degree. So 540 degree, right? Theta is 540 degree, which means theta is equal to 540 into pi divided by 180. So what you are getting? So 540 into pi divided by 180. You are getting 9.424. Right? You are getting 9.424. So again, T max by T min is equal to e power. So 0.2 into 9.424. Right? So it will get, you'll get T max by T min is equal to, so e power 0.2 into 9.424. You're getting 6.585. Right? You are getting 6.585. So T min will be equal to T max. T max is already known, which is 2452.5. 2452.5 divided by 6.585. So F will be equal to, we're getting 372.4 Newton. Okay, so now you can conclude. You can see that. So when I am wrapping around this pipe, if it is one time, which is 180 degree, if it is one time, what I am getting is, I am getting around the force required to hold that, right, to withstand that. It is around 1308. Whereas if it's wrapped two times, because of friction, the force required is very less, right? The force required is very, very less. Okay. So can you tell me, is there any possibility to neglect this force, right? So I'm going to include one more question now. What will be the angle theta if F is neglected. F is neglected. So F means my force on the other side is neglected, right? So it is like I am wrapping around those 3 or 4 times, and I am leaving that. So the object, what this 250 Newton will not come down. So it will stand at that particular location, right? Minimum degree required to wrap it. Okay. So let me consider this. So here there is one problem. So I have to identify what is my T min. T min is neglected when I say T min. So F is T min, right? So F is T min. So T min, if I say neglected, I can't put 0. So if I put 0, what happens? It goes to infinite. So I will consider as very, very small value. Let me consider it is 0.1 Newton, right? Let me consider it is 0.1 Newton. Okay. Or more accurately, I can also consider as 0.01 Newton. So it is up to me. Let me consider 0.01 Newton. Very, very less, right? So now I know what is my T max. So what is my T max? T max by T min is equal to e power mu theta, right? So T max I know, which is how much? Sorry. So 254, sorry, 2452.5. 2452.5. So we consider 2452.5 divided by zero point 0.1, very, very less value, is equal to e power mu theta, right? So which means what will get 2452.5, sorry, this is zero point 0.1 or 0.01? We consider 0.1, right? So 0.1. So 3.5 divided by 0.01. So we're getting a higher value of 245250, right? This is equal to e power mu theta. Coefficient of friction we know, right? Coefficient of friction we know. So what I am going to do is I am going to remove this mu. So E. So what I will do? How to remove this E? Yeah, you have to take ln. You have to take log, right? So ln of 245250 is equal to mu into theta, right? Because that ln and E will go off. So you'll get only this thing. Okay. So let me take ln of 245250. So we're getting 12.4. So 12.41 is equal to zero point 0.2. E power is mu is 0.2 into theta. So I'll identify what is my theta. So theta will be divided by zero point 0.2. So we're getting 62.05 radians, right? So it is 62.05 radians. Okay, in that case, so theta will be equal to 62.05 into 180 divided by pi. So I'm converting to degree. So into 180 divided by pi. So what I are getting? I am getting theta is equal to 3555.21 degree, right? Okay, so I am considering very, very minimum force 0.001. That's why. So if it is zero point 0.1, then there will be, it won't come up to this angle, right? So okay, let me divide this by 360, because when I wrap one time, the total angle of contact is 360 degree. So if I divide by 360, you are getting 9.87, which means what I have to do, I have to wrap around 10 times approximately. If I wrap this around 10 times, right, your weight won't fall. So you no need to apply any force. Are you getting it? Right? So this is one way. So you can able to see. So if you are holding what I can say. So sometimes so farmers they'll be tying this cattle or something like that. So in a tree, they'll be wrapping 3 or 4 times. Or sailor. So if you want to hold your boat, right? So what you will have a pin like arrangement or anchor, something like that. So what you will do, they will wrap this thread 3 to 4 times so that the amount of force required is lesser, right? So amount of force required is lesser, and it will withstand more, so that it won't, even though there is a force in river, it won't go off, right? That is the main advantage of this particular rope friction, right?